We have an abnormal voltage phase to ground on a 415 volts, 3-phase, 3-wire system located on an offshore floating platform where ground and neutral are common. You measured the voltage between phase A and ground to be 5 volts, phase B and ground to be 415 volts, and phase C and ground to be 415 volts. The expected voltage reading should be around 240 volts. One day prior to the measurement, one of the feeders was hit by lightning. To solve this problem, consider these possible causes and solutions. 1. A broken neutral conductor. Lightning can damage the neutral conductor, potentially causing it to break or become loose. Therefore, check the neutral conductor for any breaks or loose connections. Repair or replace any damaged portion. 2. A ground fault. Lightning can create a ground fault, which could reduce the voltage in the affected phase. Use a megger or a fault locator to identify and repair any ground fault that exists. 3. An unbalanced load. An uneven distribution of load across the phases can cause voltage imbalance. Evaluate the load distribution across the phases and ensure it is balanced as much as possible. 4. Electrical noise. Lightning can induce electrical noise in the system which can interfere with voltage readings. Install noise filters or surge protectors to reduce electrical noise. 5. A malfunctioning voltage transformer. The voltage transformer used to measure the voltage may be faulty or improperly calibrated. Inspect the voltage transformer and calibrate or replace it if necessary. 6. Incorrect grounding. Ensure that the grounding system is properly installed and maintained. Check that the ground rods are in good contact with the soil and that the ground connections are secure. Here are the steps to solve this problem. Isolate the affected feeder. Isolate the feeder that was struck by lightning from the main bus bar. Check for physical damage. Inspect the feeder for any visible damage to the cables or insulation. Measure voltages again. Once the damaged feeder is isolated, measure the voltages between each phase and ground once again to see if the problem has changed. Identify the root cause. Based on the voltage measurements you obtain, determine the most likely cause of the voltage imbalance. Implement corrective actions. Perform the necessary repairs or modifications to correct the problem. Finally, verify the solution. Once the repairs or modifications are complete, measure the voltages again to verify that the problem has been resolved.